introduce you to Skippy Hau. Skippy has been a friend for many years, somebody I've known for I can't remember how many years. He's been working for the Department of Aquatic Resources as an aquatic biologist, and for 33 years now. And he does some work that is absolutely critical for us to understand how to improve the coral reefs, and that is that he's studying the streams. As most of you know, or many of you know, the streams, that many of the fish come up into the streams, for example, in order to lay their eggs. And if the streams aren't flowing, then the fish can't come up and do that. And those fish then get washed out to sea, and they become food for other fish, and they're part of the entire food chain. So we're really grateful. I'm just so deeply grateful to Skippy for all the work that he's been doing for all these years. He's also going to be talking to us tonight about his work with the turtles, which is equally fascinating. So I'm just going to turn it over to Skippy Hau.
Oh, hello everybody. Thank you. I guess first I have to apologize because I know she's saying she's going to be taping me on YouTube, or not YouTube, but I'm not sure what the...
You're on Facebook Live.
Facebook Live. But I don't have Facebook, and I'm not on social media, so I stay off of that. And I've been working in the streams, and one of the things that I've been doing is, well, I guess I'll show you folks what I've been doing in the streams. But I've also been working with turtles, so some of you I've been working with before. But it's been really fascinating because as an aquatic biologist, I came here as a fish biologist. In the first year I came here, I had a turtle that laid a nest in Paia, and it was actually an olive ridley turtle. I'll show that later, and that's my other presentation. Okay, oh, you did change it. Okay, it is on. Okay, so my first presentation, I'd like to talk about what I've been doing in the streams. So some of our stream work. The other two folks, one is John Kahiapo and Daryl. They're from the Big Island. And then so we've been surveying streams throughout the state. So we put together a stream team, and we were fortunate enough to go and visit some of the streams. We get to fly in by helicopter and really survey a lot of the streams. So we found a lot of things. And what I'd like to present is some of my research I've been doing in, well, it's interesting because Iao Stream has also been changed. So they renamed it Wailuku River, their original name. But when I started, it was Iao Stream. When I came here, Iao Stream was channelized. So a little bit background, where did I grow up? And I grew up in Kaneohe on the island of Oahu. And in Kaneohe, I grew up and I used to go fishing, and I used to play in the streams and everything. And I never realized that things would disappear. So today, when I go back, I go to most of the streams that I used to play in. They've all been channelized. And so the streams aren't there. Or they now have also armored catfish in the streams on Oahu now, which I'm sort of grateful that we don't have it here. Let me look. Okay. First, I've been working in Wailuku River. So Wailuku River is the one in the dark blue. The four streams in Wailuku are referred to as Navai Eha. So Navai Eha are the four streams. So from Waihe Stream, Waihu Stream, Wailuku River, and then Waikapu Stream. So the watersheds, I've put in the different colors. So Waikapu is also in green. I guess what I'd like to highlight is that the watershed also includes water that normally would come off of Haleakala, would join Waikapu, and then flow out to Kealia Pond, to where Kealia flows to the ocean. The red are actually irrigation ditches. That is how they watered the sugar. They diverted the water from the streams and watered the sugar cane. So that's sort of overall picture. When I came here, so also now we have Google Earth. So it's a Google Earth shot. The two dots, the blue dots, are where we have the diversions. There are two diversions that are put in the streams. So this is Wailuku now. So in olden days, this probably what you would see in front of you would probably mostly be taro patches. And they'd be raising taro from the stream. Okay, we had two diversions. So The one here is the upper diversion, and then this one here is by Happy Valley. There are two different diversions that we have on Wailuku River. Okay, so this is the upper diversion. And what I wanted to, well, my research has been from 2000. I thought, what a great time. So I figured at the year 2000, I'll start this project. Started in 2000, but I didn't have any reason to stop. Okay, so I started doing the project. But what happened was the Water Commission had decided they were going to return water in 2014. So I've been doing research on post-larvae. These are the returning animals in the streams. So I've been doing that for 15 years. And then it gave me a good excuse to stop. So I have 15 years of data of what kinds of animal have returned in the stream. Excuse me. 2016, in September, we had a big storm. This big storm came in, and it basically flooded Iao Valley. So this is the same upper diversion. So now the stream has widened. So it washed it down. That's why I circled it in red. So it just kind of give you a reference point. Remember that upper diversion? So the stream has now become wider. So it's a totally different stream than what it was previously. This is what I don't know if you know it, the debris basin. This is up in Happy Valley. So the debris basin got filled. All of this got filled with sediment, and then trees had blocked it all up. I think they estimate like 6,000 truckloads had to be removed from this. But all this sediment and things, if we didn't have the debris basin, would have got washed out to the ocean. So it did its job. And actually, what's interesting is that in this would be the 1916 flood. I looked in the old Maui news, and what happened was there was another spectacular flood, but this was in 1916, and 13 people got killed from that flooding. So that's sort of one of the reasons and the justification that they used for this flood control project. So in actuality, it did protect people's homes as well as no one got hurt, so nobody got killed from this flooding. So what I wanted to show you, this is the lower area. I don't know if in Wailuku, I don't know if you know where McDonald's is and Second Safe. So this is actually where I come to go and catch post-larvae. This is right after the storm, so all of this debris and boulders and everything came down and washed down right by the bridge. I refer to this as the Waihu Bridge. This is what normally it would look like. So from 2000, this is what I used to do. I used to come in and I used to put stones, so I put rocks in, so they provide habitat. And then what would happen is the opai, the shrimp, and the hinana, or the baby oopu, would hide under the rocks. So I'd collect them, I'd count them, and then I'd take them up to the state park and release them. So what this project kind of gave me a better idea was how much recruitment we're having in the stream. So all I'd have is probably this little trickle. So this would be that one way that the animals would come up. So I sample this little run. Okay, just a real quick on what the life cycle of the oopu. The oopu are actually we have 5 different species of oopu. 4 of them are what we call gobies, and the gobies have this fused pelvic fin. It's the fused pelvic fin that allows them to climb up the waterfalls. Okay, let me see. So these are actually 3 of the oopu that are better climbers. So these are they're about 1 inch, so about 22 millimeters. So this is the Opu Nakea, Opu Alamo'o, and Opu Nopili. I'll just kind of refer you to the different names, and then actually I'll also introduce the scientific names later. But this is the Opu eggs we're hatching. So what I normally do is I take a piece of the egg case, the eggs that are laid on the rocks, and then I put them under aeration, and then let the eggs hatch. So those are what the larvae are looking like. And the larvae actually go out with the flow in the stream and go out to the ocean. They spend about 3 to 6 months in the ocean. And then when we have rains, the animals will come back as post-larvae. So this is sort of what I've been kind of focusing on, that return coming up the streams. This is the Opu Nakea. Okay. Like I said, I started in 2000 and all the way through 2014. So what I found out was that the opai, this is the opai kalaole, they sometimes refer to it as mountain opai, made up 88% of the animals that return. Opu alamo'o, I think I showed you a picture on the table. It's the one with the males have that orange tail. So Opu alamo'o, what's interesting is at the time they were doing genetics experiments, so they needed post-larvae. So I used to provide them the Opu alamo'o to work on for their research at the University of Hawaii. Another story I have to tell you about is Fish and Game. This would be back about 1956. It also introduced Tahitian prawns when they intentionally introduced the Tahitian prawns. So when they introduced it to Oahu and Molokai, it's now spread throughout the state. So we have Tahitian prawns. And that made up 3% of the animals. Okay. And then Oopu no Pili, like I said, one of the Oopus, made up 2%, and the other one, Oopu Nakea. So all of the Oopus are actually endemic. And then Oopu Nakea used to be considered indigenous, but the researcher who's on University of Guam actually did his graduate work at the University of Hawaii, and he went and then he looked back up and revised it used to be Guamensis, Awals guamensis, and now it's Awals stamineus. So it's now an endemic species, so all of our Oopu are endemic. I put in this category aholehole. So even in the streams, aholehole will also come up, but not enough to even make 1%. But I just kind of kept track of the numbers. Okay, so what do they look like? So like I said, when I first had water flowing into Iao Stream, what I would see is streaks in the water. So this is what they would look like, streaks on the water. And I didn't know what they were. So I used an aquarium net, I collected them, and I grew them out at home. So what I do is I catch them and then put them in a bucket. So one of the good things is that when you're young, you don't know, right? You put it in a white bucket. As you get older, then the eyes can't see as well. But I still use the white bucket so you can see better. But these are opai. I don't know if you can see the fish there is the alamo'o. And then this is what the opai, when they get bigger, they look like this in the streams. They'll hide under the boulders and rocks. So a lot of these photos, I really didn't know they were even hiding under the rocks. I had a flash. And when I had the flash and I put it on my computer, then I discovered that the opai were actually under the rocks. Opu alamo'o. Opu alamo'o is the male is here. But what I was catching was up here. There's the post larvae on top of the rocks. When you see the yellow spots, those are Hihibai egg cases. Okay, so the Hihibai streams, what you see is these white egg cases. Actually, the white egg cases carry up to about 250 eggs for the Hihibai. So they're the snails, and they'll lay these egg cases. So it stands out in the stream. This is a female alamo'o. Okay, so she's kind of mottled, but she kind of blend in. And then this is actually a male. And then what's interesting, you also have opai in the background.
When they're full grown, how
Yes.
big are they? How long?
They can get pretty big, 6, 7, 8 inches.
Oh, wow.
We've gone to above Hi'ilawe Falls. I don't know if you know Waipio Falls. It's about 1,200 feet. So we surveyed about 4 waterfalls above the main falls, and the fishes were in the pool above. Yeah, we took lunch and we ended up looking for fish, and we saw them. This is the Tahitian prawn. So when you go into our streams, and this is actually what we call a terminal growth male. What will happen is you have all these blue pinchers. So the blue pinchers, they're at maximum growth. So what happens is the prawn doesn't get any bigger. All that energy, everything goes into the prawn, the legs. So it won't, this is maximum size. So they call them terminal growth males. These are, yes.
They introduced.
The prawn, at the time, they felt that Hawaii needed more animals. So on the marine side, that's also when they introduced the ta'ape, the to'au, and the roi on the marine side. So on the stream side, that's what they did. They introduced the prawns here.
Have they been a problem?
I think people sometimes think they're feeding on, but I think what happens is when you get the big storms, a lot of times the animals get injured or even are dead. and they're omnivorous, so they'll pick on the dead one. So they think that the opu may have caught it, but I don't think so. They may have gotten damaged maybe during a storm, and then the prawns end up feeding on the dead carcasses. Yeah, so I kind of find it mixed. So I'll explain a little bit later on the other prawn. But this is Opu no pili. So normally if I see Opu no pili in Iao Stream, if you look, you can see the stripes. This is a male here. So the male would develop a black and white. I tell the kids to look for that black and white mustache. And then what happens is the males will also have this bluish tinge. What's real interesting is when the animals are bigger, they have these other colors that will come out. So really colorful. You know, they kind of look like they're bland. They kind of want to blend in. But the blues and the reds and all these different colors will stand out. This is the Opu no pili. At the intermediate size, I don't know if you can see the dorsal fin turning orange. So this is the only species that will have that orange. If you see that orange dorsal fin, then you know that that would be an Opu no pili. Opu no pili is would be our herbivore. This one feeds on algae. So when you look, even from Waihe, if you look on the bridge and you look on the rocks, they'll graze on the rocks. And then so you sort of see kind of grazing down on the algae in the rocks. This is Opu nakea. Opu nakea is our biggest. Okay, so, well, that's the big guy. It took me about 2 hours. I explained to the kids that I stayed with the different fish stations about 2 hours in the stream until the fishes got used to me and then allowed me to go in close and then take their picture. Okay, so what's interesting with this one, I also explained to the kids, this was totally by accident. These two were already lined up. I was just about to snap and this third fish jumped in the picture. So it's not my fault at all. But I also explained to the kids, I'll show you something. This is the male. The male has the big lips. Okay, these two are females. You see that little bit smaller mouth? Those are females. And then, so this guy here, I think might be a male. And that guy up there is a male. Okay, just something in case somebody gives you a quiz. So these are our 5 oopu. So like I said, the Opu nakea is the biggest. Opu no pili, which is our herbivore, and our Opu alamo'o. This one is omnivorous. So this one would also feed on insects and feed on algae and things. This one is also omnivorous. This is Opu naniha. It has this dark eye bar. So like a teardrop coming from the eye. So that's the Opu naniha. And this one is the Opu akupa. Opu akupa does not have that fused pelvic fin. So this one can't climb waterfalls. It has to stay on the lower section. But this is our carnivore. He feeds on everybody else. But sometimes this one gets so greedy that what happens is it tries to feed on something that's half its size. So what happens is that the fish gets stuck in its mouth and then both fishes die. Yeah. But this is a carnivore. Okay, what have I learned after all these years? So this is from the 14 years. So 2000 to 2013, this is before they decided they're gonna return water into the stream. I kept track of how many days that the flow in the stream occurred. So it averaged about 52 days out of the year. Okay, this is the year just before they opened.
That little trickle, you consider that trickle a flow?
Yes. So only 52 out of 365. So then on that 2014, when they returned the water in October, so about 178, so about half the year, there was flow in the stream. Okay. Sorry for the small numbers and things. So what I did was I took a look at the numbers. So this is, actually I'm looking at flow. This is how many post-larvae I collected. And then this is on the Opai. But I also looked at the number of flow days, because some days you may have only like about 24, 23. So at different years, I'd have so 20, 25 days out of the year that we had flow in the stream. Okay. So what they decided was that in 2014, they would return 10 million gallons of water into Wailuku River. So what I did, I went to the USGS. I asked for their, they take care of the discharge measurements. They measure the flow in the stream. And then so what I did was I calculated what 10 million gallons would be. And then I went back to look at the data. So this is the actual. So in 2014, what happens is that even if you return 10 million gallons, 79% of the flow is still diverted.
Oh.
Okay. So this is how much is actually staying in the stream. So that's what I kind of wanted to look at. So just to look at numbers and to look at real discharge, how much flow is being returned in the stream. What I did was I went from 2000 to 2014, and I looked at the average, and then the average discharge was 77.4. This is in what they call cubic feet per second. And that 77.4 cubic feet per second in 2015, what we're looking for is that 64% of base flow. If we return 64% of that base flow, we should get return of about 90% of the habitat in the stream. But the 64% of the flow would in actuality be equivalent to 32 million gallons of water. And so I kind of wanted to make sure that this would go on the record, so I wrote a letter to the Commissioner of Water Resources as well as my boss in a letter for documentation, because once the data is gone, and especially historical data, then people are going to ask questions, is this valid data, and this was taken by USGS. I wanted to make sure, because all the gear that was measuring the discharge all got washed away, and the discharge hasn't, the equipment hasn't been put back into the stream again. So I'm kind of watching again to also, we need actual data on how much flow is actually coming down the river. So there's a lot more rain coming into the stream. And I used the 2015 data. Remember, I told you they returned the water in 2014. So the 2015 is a complete year. And then in 2016, we had that storm. So I didn't want to deal with partial data for the whole year, because I'm looking at the annual data. But like I said, it's 32 million gallons. And then so that's what I wanted to kind of help brush upon. And then when we returned the water in, this is, like I said, October of 2014, this is the other prawn. This is our native prawn. You may hear the name Opai Oiha'a. Opai Oiha'a is the native prawn. This prawn started recruiting up the stream. So remember the 14 years or 15 years I was monitoring? They didn't come up the stream. I'd find them in other streams, but they started coming up that summer into Wailuku River, and they would come upstream. So the native prawns started responding. The other thing that I've been also paying attention to, and what I've focused my research on now, is the Hihiwai. Hihiwai are snails. These are native snails. And then, so this is a kind of mixture of different kinds of shots. So what happens is when you have big water, after the big water, the Hihiwai will line up, so they'll kind of like follow the leader. So they'll make lines like this to go upstream. Okay. What they'll also do is that when you watch, they'll come out of the water as they're migrating. So they move completely out of the water and then start moving upstream. So that's why I took that shot there. The other thing about Hihiwai is that they also piggyback. So the little smaller ones, I've seen as many as about 7 Hihiwai piggybacking on the big ones. Okay, so yeah, but it's been documented before. But I just wanted to show you that. And then remember I told you about the egg cases. So when they lay the egg cases, it's this bright white. And so you can't miss them. You can see them in the stream. So the Hihiwai lay their egg cases around. Okay, and then so they're at different sizes. As they're migrating upstream, then they'll settle. Okay, so what have we done? This is more recently. So in the last couple of months, I've been going and then I've been checking. Remember I told you Waihu Bridge? And then everybody kind of wants to say I'm the reason why the animals are going upstream. The animals are going upstream on their own. Okay, so now this is a blurry picture, but I wanted to show you this. This is algae growing on the bottom in the concrete channel. So this is a Hihiwai right here. Okay, they're migrating. In August, we picked up about 20 Hihiwai. And so now these are big Hihiwai, coming up to as many as 20 millimeter. So this is that on the lower side, towards the ocean side of the Waihu Bridge, and that's in that location there. Okay, so the Opai Oeha, since 2014, has now started to recruit into Wailuku River. The Hihibai, and like I said, now I can say that they're actually migrating on their own, and they're coming upstream because of the continuous flow. The numbers in parentheses, these are in millimeters, these are shell length averages. So normally, when I'm looking at the little recruits, they'll average between like 2 and 5 millimeters when they're migrating from the ocean. So I'm picking them up at about, this is the average, 19.5, 15.2 in July, August was 18.1, October 17.6, and November, just last week, about 16.3 millimeters. So they're no small ones, but they're growing as they're migrating upstream. And then so that's what I kind of wanted to show. I haven't even presented this to my bosses yet, but yeah. So this is just to show that it's been successful in terms of restoring the water. But like I said, I'm also asking for more water. And I'm not sure if it's before the Water Commission. And it's going to be, water is still under their decision. So, but like I said, I wanted to get data so that we can prove to at least request more water flow. Any questions? Yes?
2 questions. So the debris basin?
Yes.
That's before like this, the concrete chutes, is that right?
The chutes, and you know where the million-gallon reservoir on the side? Yeah, right over there.
Right over there.
That was all filled up. Yeah.
So that's also just the habitat that's going to be able to make it through there for the.
They'll come through. Yeah. What's interesting is that I've been looking at Kahoma Stream also,
Yeah.
and then so they've been going upstream past the.
Yep.
There's a debris channel also there. Yeah.
And do you think that 32 million gallons is kind of like a number for all streams, or is that?
Oh, no. This is just for this case because, like I said, we have data. And the problem is to present actual data and then to go back for each stream. I know it's going to be hard work. But it sounds a lot when people would say 10 million gallons. But if you're getting, so like I said, if that's only 20%, then maybe times that by 4.
So it depends upon the amount of diversion.
40 more million gallons are being diverted, yeah. So that's what I have a problem with the Water Commission. And it's to look at actual numbers and what's the actual flow. Because at different times of the year and then different storms, you have to be careful because the freshets, that's one of the things that we're trying to document is to really to capture how much actual flow. This last time with the Skippy Hau, I know there was about 20 inches of rain. We actually have a level logger. The level logger we haven't recovered because the water was too high. So hopefully this month we're going to pick up the level logger and we have actually the storm documented, how fast and how high the water went up. If you got to see the KHNL news, and they were showing that water, remember when the car was floating down? If you see that coconut tree in the middle, I normally park right there because that's dry. And I parked there, and then, but they had the car was floating in the news segment. That would normally be dry, but we work up there, so we park there, and that would be all dry. Yes. Someone had a question? Yes. Any other questions? Oh, yeah. Yes.
When you were talking about the eggshells, on the rocks. Those
the Hihibai, yes.
Yeah. Where are those mostly located? Are they down near the ocean?
Oh, actually, no. They're all over. Yeah.
Everywhere.
Yeah. Well, this would be coming upstream. Yes.
Repeat the question.
Oh, okay. She was asking where we would find the Hihibai egg cases. The egg cases, yeah. So the egg cases, like I said, are white, and then when they lay the egg cases, then you see on the rocks remnants. They'll be off-colored, and then in fact that's what I found on Iao with some of the rocks that washed down. I had old Hihibai egg cases, so it told me that the Hihibai were actually reproducing, yeah, upstream, and so that's kind of like one of the things I've been using and having people also to watch for. Yeah, they're really small, but when they see the egg cases, yeah.
And now, are you also saying, like in that concrete area right there near McDonald's?
Yes.
Down there where that goes through, there's more life that's starting to grow in there?
Yeah, because of the constant water flow. That's why you'll see also the algae in the green. You have to be careful. In 2014, that's where I slipped and I broke my, wasn't my humerus, but it took me 1 year. I had to go back. I needed to get recertified for diving, but it also made me much more careful. So the kids, they'll go like, but just took one slip and it broke my humerus. It took 1 year to heal. I'm sorry. Yeah, you had a, yes, sir.
The snail behavior will follow the leader.
Yeah, so they'll follow the lines. In fact, you know what? I have a video. Well, I'll show you what happened, but the videos I'll be showing in the next part is the videos have the Hihibai moving, but there's another story that goes with that. We flew in to West Wailuku by helicopter, and then what happened is the day before we had 30-foot swells came in. So the big waves were entering the estuary. The Hihiwai were migrating to get out of the salt water. So they moved upstream, and I have a video of that. And then somebody else had yes?
You said that you're requesting more water. Is that just for Wailuku River or for
I'm doing it for Wailuku River, but at the time, right now, they're also looking at trying to restore water to East Maui streams. And that's why it's so hard, because each of the streams are different. And then so some streams have data, and other streams are really small, but they could be. See, one of the, I think the keys for our estuaries in Hawaii is that I think all the streams together, I think, provide a useful service in terms of being our nurseries. It's not like, say, a big San Francisco Bay. They've been talking one huge estuary and things. I think over here we have a lot of small estuaries, and I think they all contribute to the productivity and the fisheries. So, our nursery grounds, and I think all the streams, I think, if they were able to flow. That's also why I don't like the Water Commission saying that because it's a losing stream, we're not going to return water to it. I think what we saw in Waikapu and the restoration of water to Waikapu is Waikapu stream has now gotten saturation. And if you notice, Kealia is now almost always full of water. So we don't get the dead fish, the tilapia, or the midge problem anymore. We don't have a boom bust cycle. Everything just kind of dried up. Then we have dead tilapia, and then we have midges. We don't have a midge problem anymore. Well, I'm saying that, but hopefully we don't get to see midges again. You had a question?
Sure. At the beginning, you said the streams they used to play in Maui have become channelized.
Yes.
I don't know what channelized is.
They put concrete. So when you see like Kahoma and then Iao Stream, then what they did was they come in with they're part of a floodplain project by the Corps of Engineers. That's why it's so hard. I've been working with the Corps of Engineers, so I'm kind of like working with my fourth generation of engineers and fish and wildlife biologists. And then I've been trying to tell them, return water. If you return the water, the animals will come up on their own. So even like for Wailuku River, there's a 20-foot drop, and they're still trying to tell me that they want to put in a fish ladder. And I told them they don't need a fish ladder, just return the water and they'll climb the wall on their own. Yeah. Yes?
What is this 10 million gallons of water count on? Are there reservoirs?
The 10 million gallons was decided by the Water Commission. That would be the Water Commission was Dr. Lawrence Miike. I guess they get to look at the discharge data in the streams. And then they, as a group, the Water Commission decided on returning 10 million gallons to the stream. So the discharge is reported in cubic feet, what we call CFS, or cubic feet per second, how you measure, and then million gallons per day. So that's why I don't know if you saw the data, I had it both in CFS and million gallons per day. The problem I have also with the Water Commission is not speaking in one terminology. They'll have all these different formulas, and it kind of gets confusing when they start talking about discharge and data. Yeah. You have a question? Yeah. Yeah.
What are the benefits to the ocean?
That's why we're doing our estuaries surveys. So we're working at Kealia, Honomanu, and then Honokohau. And what we've been doing is we've been sampling. And so we've been looking at recruits. So looking at fishes, if you catch shrimp, if you catch crabs. we're looking at the productivity in the estuaries. So we're sampling at different times of the year. And so we're looking at that. We're looking at, we'll also pick up even to'au that was introduced, but we'll find them inside the stream mouth. Yeah. And then, well, we even pick up small baby, what they call ohua, or these are, I don't know if you heard of the name ohua, but they're baby manini. That's before they start to get their stripes. And so a lot of the folks who grew up on east side, they used to tell me in the 20s and 30s, they used to catch them. And then that was like a delicacy. So they catch them and then dry them. And then, you know how like the irako, the Japanese will dry the fish, and then you eat that as a snack. Yeah. Yes, ma'am.
So the water in the beginning comes from the rainfall in the
Yes, in the watershed.
watershed.
Yes.
So it's the rainfall that has been diverted, and then
Right. So what they're doing is they're diverting the water. And then what they did for East Maui is that with the situation with HCNS, so for A and B, they've kind of reserved an amount for diversified ag, but they haven't declared what they're going to be farming or raising cattle. There's no real clear demand, but yet they've set aside a number or amount of water that they say they want to divert the water from East Maui streams. And so I think the other folks are just saying, why not just let them return the water to the streams? Yeah, but it's, like I said, it's a water commission's decision. Yeah, yes, ma'am.
Okay, two things. One, to follow up on his question. There's 10 million
Yes.
gallons that the Water Commission has said that they would release.
Oh, it's being released right now.
Being released.
Yes.
Where is the data that supports that 10 million? Do they have any justification, any research that justifies, or did they just pull that number out of their hat?
That was from all the evidence and testimony that they received.
Testimonies.
Testimonies.
Scientific evidence about what that 10 million.
I can't answer how they decided on it. That's why it was such a prolonged situation with the Navai Eha case. That's also why it's sort of nice to see that they're releasing water in West Maui prior to getting they're at least releasing water in the stream instead of waiting and thinking that they're going to come up with an exact amount. It's better to at least release the water and then we'll see whatever. Well, originally for Navai Eha, we had requested that they get controlled releases. So with the controlled releases, we would be able to monitor what happens in the stream. But they never agreed to it. So that's why it's kind of interesting. So now with the water flowing in Waikapu stream, then to see how Kealia. But don't forget now, that's also one of the reasons why I think Kealia is, I think, one of the most important of the four streams because of the wetlands as well as the estuary, because of that water. And I think we need to, if we maintain the ecosystem, I think we'll have better benefits. So, yes. Okay. Yeah. Just like.
Question in the back about the estuaries.
Yes.
I'm a Laurel fish plankton biologist.
Yes.
By trade, and our estuaries, the freshwater mixture area is one of the most important productive areas for our fisheries and for our whole coastline. So if we don't have that, and it also was very much recognized by the Hawaiian fish ponds. You need to have that freshwater
Yes.
runoff in order for the system to work.
Yes.
It doesn't matter how much individual data you want, you gotta have that water there.
Yes. I agree. That's why I'm still promoting, but like I said, I'm trying to also get the estuary data. So it's kind of to get and document the ecosystem to justify. That's why it's so hard, because what I'm looking at, like I said, the post-larvae, I know people are thinking, well, why am I looking at this small little fish? But if you don't get recruitment, they grow into the adults. And then, like I said, and the kids at least understand the life cycle, and then they can reproduce in the streams. And
Can
yeah.
I just ask one
Yeah.
question?
Okay.
If they're not having the water diverted to the sugar cane, where's that water going?
For West Maui, that would be Wailuku Agribusiness is diverting the water. And then they're actually charging people for water delivery to West Maui. So it's kind of interesting because I think what's interesting, if you look, they'll water like certain taro patches, and if you watch the water flows through here, but then they're charging the different farmers. So the same water flows through the fields and goes through. Yeah. Good. Okay. Well,
Thank you very much, Skip.